Hello everyone, welcome back to Structure Expert. Today we continue to output structural detailing in Tekla Structural Designer later current version 2022. Now let's start. After we complete analysis and design wall, column, beam, slab and foundation with pie cap, now we continue to detailing. You can come back, click on the structure 3D and right click again to view view, and you can click on the status or element path, and now let's check and detail one beam. Okay, and let me select this beam to detailing and right click click on the generate drawing. Click on generate drawing, and the drawing is beam detail, layer style, beam detail and scale. You can change the scale to 1/5, 1/10 or 150 or 100. Now let me select 150, and minimum text block spacing you can change it. Now let me keep it. Click OK. The AutoCAD will be launched. Waiting AutoCAD complete opening. In Tekla Structural Designer, you can output a detailed drawing, but this detailed drawing is not complete. You can modify it, and for the tender you can use it to view the section. Just enter. Yes, now let me. Yes, this is the section of the beam. You can check the section of the beam. Section A, and section section GG. This section cut AA, BB, CC to the UU, and at the section AA is the diameter rebar. Diameter rebar is 20, and at the bottom is 16. Now you see here the beam. Okay, the beam is 500, but the slab is 150 over the beam. It's not connect each other like this one. I will show you. Copy. Call our concept, want to design this beam. Press SH. Okay, SH. Okay, this one. Let me move it. Okay, strike it. Okay, now I can strike it to 140. Okay, this one, and the dimension DLI again. Yes, you can 500. You can change the text style, the style of the touch. Now let me increase it to 300. Click OK. Set current, close. Again DLI. Okay, see here 500. Okay, so we want to use this beam and the slab connect each other, so you have to come back and check in Tekla Structural Designer because the alignment. You can change alignment of the beam and the concrete. Okay, this is the alignment of the beam and concrete. Let's check. Beam and concrete slab is over here. Now let me come back to the structure and back less. Okay, now you can check this is the beam. Yes, beam, the section of beam is 250 multiplied with 500, so this the height of beam, and over the beam is the slab. The structural the Tekla will be use the beam and the slab connect each other at this section. You can check. Yeah, section of beam connect with the section of the slab. In the case you want to use this style, you have to change the alignment and come back to run like C design. This is how you can fit the model. Let's check on the alignment. Where is the alignment? Let me find it. Yes, this one alignment. You can change it from the top to the center or to the bottom. You can change it and check, or you can check for the slab. Okay, you can change the alignment. Now let me find the alignment. Where is the alignment? You can change the alignment of beam or alignment of the slab. No alignment. Okay, you can change for the beam, and after that you can check the connect between beam and the slabs. It's okay or not. Yes, now let's continue to the output detailing. This is the layout. This the layout of the beam. Here the diameter and the rebar arrangement, but this style is not recommended in my local here. We use the DB with the length 12 meter. Okay, 12 meter. After 12 meter, we will use left length to continue to use this rebar. But in the Tekla Structural Designer default, they did not use the bar length 12. Here this bar segment, and after this segment, continue to other segment and segment. Split it several segments, and this is the beam. Yeah, beam other side. Yeah, other direction, and this the slab. Okay, and the section cut A, B, C, and the overall dimension or span 5.5 meter, 5.5 meter, and this one the total is 16.5 meter. Yes, and the grid line 1, 2, 3, and the dimension of column 700, 700, and 700, 700 is the same. This is the span number 1, 2, 3, and the beam section is 250 multiplied with 500. And the output by Tekla Structural Designer version 20.0.0.49. And this is the section cut of the AA BB. Now let's check for the rebar. Just type H A10 A25, the total length, the total mass. So total mass in the beam is 400.59. Yeah, this one is the quality, length, the total length, and the shape, and the member. The shape is you can check according to the code. If you design code based on the Euro code UK, and the shape is U for the UK, and you should check with the catalog of the shape. Yes. Now we complete for output detailing of the bar of the rebar in beam, and the section cut of beam, the total summary, total weight of the rebar, and rebar shape. Now let me come back to the Tekla Structural Designer, and you can change the option. Okay, let's change it again, and change alignment of the beam to correct this concept. Yes, to change alignment of the beam. Now let me continue to the other part. We can continue to the slab, and Now let me click it again, review, yes, and drawing. The drawing, you can click on the setting. Yes, setting, you can change in the setting. Beam, you can use to show the beam size in the part8, or you can show the grade or camber. If you want to show the grade, you can take it out. If you want to keep it in default, you can take it. Include the beam name, you can include it inside or below. Now let me close AutoCAD. Quick without seal. And the beam attribute position, you can change it and check in the drawing. And brace, column, wall, you can change in the default setting. Position, reaction, beam, this setting you can change and check it. Now let me close it. And drawing measurement, yeah, general drawing, position, reaction, and you can add. Now let me close. Schedule measurement, you can add it. And the column schedule. Now let's click on the column schedule. Yes, okay. And you can output the column schedule. Select the scale. Let me use scale 1/50 or 1/25. Yes, choose 1/25 or 50. Now let's try and click on OK. Please wait the AutoCAD 2020C just load, and after complete open, you can check the drawing. Yes, this is the output drawing. Now I just click on no. Yes, for the column. Okay, this is the ST story 17, and the total height is 54.2 meter. And now let me check at the base. Yes, the base starter bar. The column, the design group, we have two design groups, CO C1 D2 and CO C1 D1. The 24 column, and this one is 22 column segment. Yes, from floor to floor. And this is the reinforcement in column for the link, and for the column dimension 700 multiplied with 700 millimeter. A, see here the A is A20. The diameter of rebar is 20 millimeter, and B for the link, and for the link, yes, link rebar. You can check it. Yes, this one is the same, is A20, and column is 3.2 meter, and from the story 1 to the story 2 also 4.2 meter. And this is the vertical rebar and link rebar, and you can check it from the bottom to the top. Yes, this one as below, we use the same dimension and the same rebar. So from the story 3 to the story 15, use the same below, and you can design and optimize it, but in the case we use the same. Yes, and the last story is story 16, and the A is equal to 13. Yes, diameter rebar and diameter rebar. Now let's change for the type. Yes, we use there are 4 types: H and H13, H16 and H20. This is the diameter rebar. The diameter of link is 8 millimeter. Diameter of vertical rebar is 13 and 16 and 20. You can check the vertical rebar is 13. Yes, for the Singapore and 13. Yes, this floor is this story is 16. Now let me come back and check the mark 1 tie diameter rebar D20 DB20. You have diameter rebar 20 millimeter. The quantity is 160. The length, total length in millimeter, and total length in mat. Shape, here the shape you can check with the shape 34, and the member C1 C2 C3 C7 C to the C48, and mark 2, yes, it's the same. You can check here. Now let me open the Tekla Structural Designer again. Click on the wall schedule. You can tick one floor, or you can tick it all, select all, and click OK. Yeah, you can change the wall scale, okay, output scale. Click OK. Okay, now let's check with the wall. Yes, from the story B1 base, the wall dimension 200 multiplied with 300, 200 multiplied with 250. You can check with the wall name W91, 92, and the vertical rebar is 60. Yeah, the amount of rebar in this wall panel is 62, and diameter rebar is 8 millimeter. You can count it. 62. Yes, 1 2 3 4 5 6 7 62. And the wall dimension 200 multiplied with 3000 millimeter. Yeah, all bar B for the length, and for the length we use 3.2 meter, the story height, and the total length rebar for the story height is B and C is equal to 36. Okay, 36, and B, yes, this one. Now let's move it. Okay, press SH again, and this for the bar shape C. You can check. Okay, yes, it is similar with column as below, and at the top. Okay, now let's check the tie or the rebar diameter. You have 8 millimeter and 13 millimeter, and the unit mass, total length, and total mass. And the grand total is 22.4 tons. Yes, the total mass in kilonewton. Now convert it to 22.48 tons. And the mark, ties, quantity, length, total length, shape, and the member. Now let me come back to Tekla Structural Designer again, and let's click on drawing. Now let's click on the wall and the V1, just V1, and you can generate arrangement, beam and force, and foundation reaction, loading, mat, slab detailing, and foundation. Because there are two different foundation wall, for the mat foundation or the elevator at the bottom of pit. And now let's view in 3D. Yes, the elevation at the bottom of pit or the elevator, and this one at the pie cap wall. Just there are different tool wall or the foundation. Now let me come back. Okay, and click on the general arrangement. In the general arrangement and plan section elevation, now scale, you can change the scale. Let me click OK. Okay, now you see the now you can quick without seal, or you can again come back to general arrangement. Yes, okay. And you can keep it the same with the other story. This one we show for the main foundation, and you can show for the pie cap and for the column arrangement. We use it the same concept. Yes. Sorry. Now let me click. Yes. Okay. Yes. This is the layout of the wall. See here the wall name W91 and the wall dimension is 200 multiplied with 3000 millimeter. You can change the dimension, because actually in the drawing you have to edit it. In the output of the Tekla Structural Designer is not yet complete. We had to change to the actual drawing. Okay. Yes. And this the grid. Yes, the grid, the construction line 95, and you can check for the general arrangement. The wall is minus 3.2 meter, scale 1/1000. Now let me come back and click on the base to show the pie cap. Okay, use the same concept, apply the general arrangement, click OK. Okay, this the arrangement. Yes, the base, the wall minus 0.2 meters, scale 1/100, and the grid line 1 2 3 to H. And then you can change the grid line in Tekla Structural Designer. 10 B C D E S. And you can check for the setting for the pie cap, column, foundation. Okay, you can tick on or tick off. Now let me show it again. General arrangement, click OK. Vào, click on yes. Okay. Yes, for the column 700 multiplied with 700 millimeter, and the wall for the basement. This is the column, and this one is the best. Okay, best plan layout, and you can edit it for the official drawing. This drawing is not complete. You have to correct some issue. For the detailing drawing in construction site, you can use this drawing directly. You cannot use this drawing directly because it has a lot of error from the output structural drawing. So to make sure, you have to edit it or draw it again. Okay, this is how you can output from Tekla Structural Designer quickly. Yes, again and again. Please correct the drawing before you make the official drawing to consultant or to the construction site. Okay, let me continue to the story 1. Now let's click on story 1. Okay, again click on general arrangement, click on OK. Yes, this is similar with the pie cap arrangement, the beam and you can check. Yes, the beam 250 multiplied with 500, and the column, this is the floor plan layout, you can check it. Now let me show in dry C. Yes, for the layout or the story, you can check it. Again, and for the beam and force, you can output beam and force, the foundation reaction, loading part, and slab mat detailing foundation layout. Now let's click on the foundation layout. You can check for the foundation layout or piling plan and the foundation layout. Now let me start from the foundation layout. Click OK. I'm really sorry because my AutoCAD now get error. I will fix it later. Yes, in the floor plan layout, you can use the floor plan layout, the slab signal and the slab name and the beam. Yes, beam 250 multiplied with 500, the grid line for the ST1. And now let me close it. And again, we use the same concept. You have to view for the foundation. Yes, and you use the option foundation layout. It's similar when I use the general arrangement I show you. You can check it. But now check for the piling. Yes. Okay. The pie cap layout. Yes, and the pie cap name. This is the pie cap layout. You can edit it for the official drawing. Yes, the pie cap rebar arrangement, and this is the mark and the LH LY dimension of pie cap tip. High data, diameter 800, length 20 meter for the ball pie, and the rebar arrangement. Okay, the unit mass type you are 825 millimeter diameter rebar, and the total length and the total mass. And this one for the ball pie. Yes, location of the ball pie, you can output the this location for sphere in case you model the ball pie correctly, and the location of the pie and the pie cap. You can use this data for the sphere to see the location of the ball pie and the axial load in each pie, and lateral force and the critical load and the critical limit. The limit is 3000 kilonewton, the limit bearing capacity of this single profile and the actual load in each profile. You can check and verify it. Okay, now let me close it again. Okay, it is similar when you use arrangement, and you can use the function reaction to display the function reaction. You can show for the reaction. Yes, now let's change it. The orientation of the dissection is 0 degree. Now let me close, and again now let's come back to view the story and click on loading plan. You can click on loading plan, click OK. Now to view it, now let's click on the slab mat detailing. You can detail for the top reinforcement, bottom, or punching reinforcement. Now in the case we do not use punching reinforcement for the beam slab system. For the flat slab you can include design for the punching and output drawing. Now let me click all to show all rebar in one drawing, and slab make layout the scale 1/100. Click OK. Yes, you can check here. T1 at the top layer 1, A11, and B1, AH. Yes, from one panel to other panel. You can check here. The type AH, A9, A10, A13, and the unit mass, and the total mass, and the total slab detailing. Yes, allowance is 17 tons. Yeah, we use a wire mesh. Because you can check with the wire mesh of the A8, A9, and A10. Okay, if you do not use a wire mesh, you can change it to use the rebar arrangement. This drawing we show for the rebar arrangement. Now let me close the drawing again. Come back to Tekla Structural Designer and made footing. Okay, now let's come back to the base. For the mat, now let's click on the B1. Yes, B1 2D. Click on the option can detail for the slab and mat. Yeah, this is the mat foundation below the pit. Click on all the scale 1/100. Click OK. Yes, the detailing for the mat foundation. Yes, B1, B2. Yeah, H20 spacing 150 and A20 spacing 150. The B2 layer and the wall name you can check it. Okay, the layout with the bar arrangement. Yes, the thickness is 1200 mm thickness of the mat foundation. The level is minus 3.2 meter and scale 1/100, and the diameter of the bar is 20. Unit mass total length total mass is 3.2 tons plus 10% slab detailing allowance. Okay, the net rebar is 2.96 tons plus 10% slab detailing allowance. Now let me close this again. Okay, this is the way you can show the outline, the plan, the column layout. For layout arrangement, you can do a general arrangement. You can output slab detailing, foundation layout, foundation reaction, beam earned. Now we complete for the modeling, analysis, design, and drawing from the Tekla Structural Designer. Yes, you can click on this view. Now let me click on the frame 10 2D. Yeah, you can copy it to the about floor, because in shooting we not copy to all the floor, so you can check it again. Now it's simple. I will output this drawing. Click on it, click on the drawing, click on general arrangement. Yeah, again general arrangement, click OK. You see the way you can show the drawing. You can check the drawing and you can output it to the AutoCAD file. Okay, that's it. Yes. Okay. Yes. Okay. Here you can show the layout of the frame 10. You can come back to check in the 3D. Now let me check in the 3D view only. Okay, this is the grid line. The grid line A, you can change it to B, C, D. The grid line A, B, C, D, E, S. And now let's check this one. Yes, this is the grid line 10. You see here, this is the grid line 10. So you in the grid line 10. Yes, in the grid line 10 you see this layout or this frame. Okay, let me show you. When you want to show other location, you can use this one, add the frame, and frame 1, frame 4, frame 5, frame 8. You can add new frame by using frame, and after that you select to one view. Okay, now let me 1, 4. Now let me view on this section C. Okay, now let me view on the grid line C. Okay, click on C. Click on C. Now come back to home, beam, model, and frame. Okay, now click on frame and you click on the grid line. Okay, now click on the grid line C. You see here there are frame 1, 4, 5, 8, 9, 10 AS. Now we have to add grid line C. Click on here. Okay, you see the grid line C automatically create, and after that you can open view. Okay, open view. This is the way you can use the grid line to you in the frame. After that, click on the drawing again, click on the general arrangement again, click on OK. Yes, okay. The frame C scale, the frame C, grid line C, general arrangement, grid line 1 2 3 4 9 5 6 7 10. You can change the grid line in Tekla Structural Designer. And B1 minus 3.2 meter base. Yes, this is the general arrangement of the frame C at the grid line C. This is the complete design and drawing in Tekla Structural Designer. Now let me come back to the 3D view. Oh, visual data. Now I don't want to show you data. I want to show in this 3D. Again, let me show you one beam. Okay, let me click one beam, click this one, and yeah, open member view. Right click on open member view. See it? The way you can show the member view. Okay, beam, column, and other beam direction. Thank you for your watching. I hope you enjoyed this tutorial how to analyze and design residential building 17 story in Tekla Structural Designer later current version 2022. It is a very informative and good tutorial that you ever seen in YouTube. You can check in my YouTube channel. You can subscribe and request other new tutorial in comment or in group. Okay, let me check in my channel. Yes, you can start from the basic 1, basic 2, basic 3. I show you the basic step from step to step, how to modeling, edit element, and how to make a different model from the grid line or from the copy from one floor to one floor. And this is for the attached tutorial for the tall building, to the actual shortening, and how to verify correction. Tall building lecture, you can check for the lecture 1, lecture 2 to gain more knowledge about tall building. It is very basic concept. We not focus about complete formula. It is very simple. You can understand it, and how to design tall building, and to discuss analysis and design in a tape by using a P data analysis. How you can cover with the P data, big P data, small P data, or critical load factor. Yes, also in critic Advanced Design 2020, how to verify big peta and small peta implication factor, and how to verify sphere or non-sphere, how to analyze design rough function in Critic Advanced Design 2023. There are a lot of tutorials in this channel, you can check it. I also explain you from the beginner level how to design the pie and pie cap in a tape in Critic. This is the theory, soil spring stiffness, physics, which use bush wall, and there are a lot of tutorials in here. Let's start and vote and comment below. I will answer you. Thank you for your watching. I hope you enjoy this tutorial to gain your more student. Please recommend this channel to your friend if you got more knowledge and very good information from this channel, and join with me. Thank you. I hope you grew from there today. Thank you.